Hi everyone. Do you hear me okay? Okay, so my name is Meir. I'm a software architect at Redis Labs. Redis Labs is the company behind Redis. Before I will start, I wanted to ask you and to get to know you a little. So, who here ever heard about Redis? Everyone, right? Okay. And who ever used Redis? Okay. And who ever heard about Redis modules? Okay, no one. Okay, so today I'm going to talk about a new tool that we recently developed at Redis Labs, which calls RedisGears, that allows you to extend the Redis capabilities and achieve things that just with a vanilla Redis you probably can't achieve, or it will be very hard to achieve. So I saw you all familiar with Redis, so I'm going to give a very, very short introduction to Redis. It's going to be like 5 minutes, so whoever didn't heard about Redis will get to know Redis a little. And then I'm going to talk about RedisGears and what you can do with it. I'm going to talk about how you can do a streaming processing with RedisGears. And after I will show you what you can do with RedisGears, I'm going to talk about the internal implementation and some internal stuff about RedisGears and the integration with Python, of course. And I hope I will get to it. I'm going to show you a cool example that combines Redis AI, which is another module we developed. It's an artificial intelligence on Redis, and how Redis AI and RedisGears can cooperate to achieve classification and AI modeling. So let's get started. So first, what is Redis? For those who don't know, Redis is an open source BSD license. It's a key value stores that allow you to store your data in a key value, and the value can be many things. Like it can be strings, it could be hashes. Hashes is like a dictionary in Python. It might be list, set, sorted set, and even geo data type. So you can ask geo queries on your data. It supports replication. It has Lua scripting capabilities, so you can run your Lua code on Redis, and lots of other stuff. But instead of just reading my slides, I'm going to show you. So I'm going to start a Redis server, and I have a Redis server running. And the usual way to work with Redis is not the usual, but let's say for starters, it's easy to use the CLI. So Redis has a set of commands that you can perform on the database. And the most simple command is the set command. The set allows you to set the value of a key to a string. So for example, here I'm putting the key foo, and I'm setting the value bar. So you can see I got an OK reply from Redis. And now I can use the get command with the foo key to get the value back, and I'm getting the variable. Do you see it okay? It's big enough, right? What? No. Is it okay? Okay, so you can see that I'm performing the command foo, and the command get, and I got the value bar, which is the value which is stored in the key foo. Now I can put other data type inside my Redis keys, and the most, let's say, common data type after the strings is the hash, which is equivalent to dictionary in Python. So I can do age set. Age stands for hash, and x1. And you can see that if I will do age get on the key age with the field x, age, I'm getting the value 1. I can also do age get all on age, and I will get all the keys, all the fields and the values in the hash. So if I will, for example, put another one, I got all the keys, all the fields, and all the values inside my hash. Now, there is also more data types like lists, as I said, sorted set. I'm not going to show it all, but for those of you who don't know Redis, which is not a lot, I'm suggesting you to try it and to play with it yourself. So after we understand what Redis is, I'm going to talk about what RedisGears is. Now, I saw that most of you didn't heard about Redis module. So since Redis 4, it is possible to extend the Redis capabilities using modules that are loaded into the Redis server and extends the capabilities. They can add more commands. They can add like functionality of saving to the disk and stuff like this. And we at Redis Labs recently developed RedisGears, which is a module that loaded into Redis and extended its capabilities. Regarding RedisGears, we at Redis Lab developed more modules like Redis Search that allows you to do a free text search on your data in Redis. We developed Redis Graph, which allows you to model your data as a graph on Redis. We have time series, we have JSON, so if it interests you, so look into it, and you can find all of our modules in our website. So back to Gears. What RedisGears is. So let's assume I have my Redis data type. It's easy, it's nice, and I can use it. It's simple. But what, for example, if I want to count a specific value inside all of my hashes? Now, currently, on a vanilla Redis, the way that I can do it is by getting all my data from Redis to my client, and then count it on the client side. This is inefficient because I just want to count and I need to transfer all the data on the network. The second way to do it is using Lua script. Now I can send my logic, write my logic in Lua, send it to Redis to be performed on the Redis server, on the server side, and then gets only the reply. The problem with Lua is that first, who likes Lua? Who knows to write Lua? Oh, it's more than I expected. So Lua is not that familiar. I especially, personally, don't like Lua. I love Python. And the second problem with Lua is that it doesn't work on cluster. So if you will send your Lua script to one shard on the cluster, it will be executed on this specific shard. So if you want to do multiple aggregations, for example, group by, get result, another group by, you will run into issues and it will be very hard to achieve with Lua. So here comes RedisGears, and what RedisGears allows you to do is first it gives you a Python interpreter inside Redis, embedded inside Redis. So you can run Python code directly on the Redis server. And the second thing it gives you is cluster operation and map reduce operation. So using RedisGears, you can do multiple group by operation and get the results. You can map your data and get results. You can filter out some of the data. You can count, and you can mostly, or you can actually do whatever you want because you can write your Python code to do it. And the nice thing is that it's almost always agnostic to the number of shards you have. So if you are writing a gear script that runs on a single shard, and then you want to extend your data and have a cluster, you can still, almost on all use cases, you can still send the same gear script that you send to a single shard, and it will run on the cluster, and will give you the same result on the cluster. You will not have to change it. So, how does it work? Oh, sorry. So this is a simple example. We have RedisGears works in a pipe. So you need to create a pipe of operation that your data will go through. Here, for example, we have our first operation, which is the reader. It reads keys from Redis and passes it to the second operation. Here is a map. And in this simple example, we have only two operations, so the results from the map is going directly to the user. So here, for example, we have a key value that reads by the reader, passed to the mapper. The mapper maps it, in this example, to 3 files or something. And then the results are getting to the client, the user. More generally, Gears allows you to define the pipe of operation, and each key value in Redis will go through this pipe, such that the result from the first operation will go as an input to the second operation. The result from the second operation will go as an input to the third operation, and so on. The last operation result will return to you as the reply. Now, it's important to specify that the first operation is always a reader, because we need to read data. We need someone to supply us the data. We currently implemented the keys reader that allows you to read the keys from Redis. We have a stream reader that allows you to read a stream data type from Redis. Whoever heard about the stream data type in Redis? Okay, so a stream data type is like Kafka. It's a queue of messages, and the stream reader allows you to read the messages from this queue. And we have the Python reader that allows you to write a reader in Python. So you can read from wherever you want. You can read from a file system. You can read from Kafka. You can read from wherever you want and pass it to the pipe of operation. Now, each data that passes through this operation, I call it records. So if I will use the name records in this talk, you will know what I mean. And we can start seeing some examples. So to show you an example, I don't want to use the slides. I'm going to show you live examples. Okay. So I will start my Redis server. And this time I started it with RedisGears loaded into it. So you can see here that RedisGears writes some logs into the log file. The log file here is just it just goes to the std out, and you can see the version and the git and some configuration that Gears automatically loaded with. You can also see that Gears specify that it could not initialize Redis AI API. I will talk about it in a while, and now we can start performing Gears executions or operations. So the way we do it is, let me first put some keys inside my Redis. So let's do like x1, y2, and z3. And now I told you that modules can extend the Redis capability. So modules can add commands to Redis. So I will have, for example, the py execute command. The RG prefix stands for RedisGears. And you can see that I have the py execute command that gets a Python script. So here I'm going to write a short Python script. And the way I'm going to do it is I'm going to create a pipe of operation. The way to create a pipe of operation is using the Gears builder. This creates an empty pipe that contains only reader, and the default reader is the keys reader. So if I will run this pipe, you can see that I'm getting all the keys and their values. So this is nice. Another way that I can do it, I can use another reader that calls keys only reader. And this time I will get only keys, because the keys only reader do not care about the values, and it just reads the keys from Redis. Nice. So what if I now want to get only the values, right? So let's use the default reader that gives me the keys and the values. And now I want to map each record to values, only the values. So the way I'm going to do it is I'm going to add a map operation. And I'm going to give it a mapper function, a lambda function, that gets the record. Let's call it R, the record. And let's get only the value. So you can see now that I'm getting only values. Okay, so this is nice, but what if I don't want the value 2? Or let's say, yeah, I don't want 2. 2 is not important for, I don't know what reason. So I can add another operation to the pipe, which filter, and I'm telling the filter to only get values, let's call it record, to only get values which are not equal 2. And you can see now that I'm getting 1 and 3. Okay, now we can complicate it even more. So for this example, let's do it like this. Let's add another like t with the value of 2. And let's add e with the value of 3. Okay, so let's assume that I wanted to uniquely count how many unique values I have. So I can add another, now I have the values. So I can do this thing, sorry, count. Oh, sorry. I forgot the, sorry. Sorry, I forgot the, we have the count distinct, I forgot the name, but let's assume I want to count how many values, not the distinct values. Oh, sorry, maybe. Never mind, but for the simplicity, let's just do count and you see I'm getting a, yeah, because I filter. Okay, now I'm getting 5 values, which is all the values I have, and if I use the filter, you can see that I'm getting 3 values because 2 of the values are 2, because I added 2 values which are 2. Maybe I will remember after the, but never mind. So this is what you can do with RedisGears. You can actually create the pipe of operations and do whatever you want with it. And now, after we got through those examples, you can also use, for example, the count by, and you can tell it by what value to count. And then you will get, for example, here the value 3 appears 2 times, the value 1 appears 1 time, the value 2 appears also 1 time. So you can do many of those stuff. You can do a group by operation and add and give your own reducer to reduce the data. And let's see a more real example, like real life example. So. I'm going to restart the Redis, so I will not have the old data from before. And what I'm going to do now, I'm going to add some IMDb data into my database as hashes. So you can see, if we will do like the DB size, you'll see that I have around 30,000 hashes on my database. And just so we will see how the data look like, let's use the scan. And let's see, let's get, for example, this key. Okay, this is not a good key because what I want to show you is that there is a genre field inside my data, and it contains the genre of the movie. But let's take, for example, this key. You can see that the genre is comma separated. So a single movie can have multiple genres, like it can have drama, short, drama, action, I don't know, multiple genres. And what, for example, if I wanted to count for each movie, for each genre, how many movies have with this genre? right? So let's use again my gears builder. So okay. So we create a gears builder. Let's use the keys only reader. I want to just read the keys. And I want to limit for, just for now, the number of results I have, because I want to see them, and I don't want the screen to show me 30,000 results. So let's do it 5, for example. And let's run it. OK. So you can see that I got keys. Now, what I want to do is I'm going to map each keys, and I'm going to extract the values from the keys. So the way I'm going to do it is I'm going to use execute command, which perform a command on Redis directly. And I'm going to do get to the key and the field genres. So now I have my genres, but it's still multiple genres, right? So I'm going to add another operation called flat map. Flat map operation is an operation that it's exactly like map, but it one-to-many mapper. So it gets one record and might produce multiple records. And what I'm going to do is I'm going to give it a lambda function that gets the record and perform split by comma. So you can see now that I have the records, but this time they are a single genre in each record. And what I can do now, and this is the last operation I'm going to add, is I'm going to add count by. By default, count by the record itself, the value itself. So if I will run it now, you can see that I have like 3 drama, 1 mystery, and whatsoever. And the next thing I need to do is to remove the limit, because now I can just count the entire data. And you can see that in a single Python line, I'm getting for each genre how many times it appears in the database. Is that clear? OK, now I told you before that it doesn't matter if I run RedisGears on a single shard or on a cluster. So let's try run the same thing on a cluster. So what I'm going to do now is I'm going to create a cluster with 3 shards. And I'm going to put the same data on it. And I'm going to connect to it and run it. I run the simple. I didn't change a thing, right? And I'm getting the same results without changing a single line in my gears execution. So this is the power that RedisGears give you. And I want to talk a little about how it works on cluster, because it's pretty easy how it works on a single shard, right? It's run the Python interpreter, run your Lambda function, and get you the results. But on a cluster, it's a little more complicated. And the way we do it on cluster is each shard handles the execution locally as long as it can. So for example, the map, the filter, all those operations that can be calculated locally is handled locally on each shard. And then if you have a count by operation, group by operation plus reducers, then we start to shuffle the data such that each record records that belongs to the same group will be located on the same shard. And after that, we can perform the reducer. If the reducer is count, we can now count all the values, because we know that those values are located on the same shard. So if we take this little example, For example, here I have on shard 1 the keys with the value 1, 2, 2. And on shard 2, I have the keys with the value 2, 3, 1. So at first, all those values are read by gears. So on the first shard, we have 1, 2, 2, and 2, 3, 1. Then gears perform reshuffling of the data. So you can see that 2 moves from shard 2 to shard 1, and 1 moves from shard 1 to shard 2. And then we can perform the count by. So here you see that shard 1 count 2 3 times, and shard 2 count 3 1 times, and 1 2 times. And after that, there is the collect phase that collects all the values back to the initiator, to the shard that initiates the execution, and this shard returns the values back to the user. So this is how it works on cluster. Now, you might say that it could be inefficient because you need to move a lot of, or in some cases, you need to move a lot of data between the shards. But we gave you, as the user, the ability to give us the local reducer and the global reducer. So if, for example, you know that you want to count values, you can have the local reducer count them locally, and then the global reducer will just sum all the values from all the shards. So it will be much, much better. Okay, so I want to talk a little about streaming with RedisGears. So RedisGears, other than performing a batch operation, it allows you to do streaming operation on Redis directly. And the way you can do it is by specifying register instead of run. And the register operation will be, then the execution will be performed for each key that added to the database, and not just one time. So this is another way to use RedisGears. And now let's talk about the internal a little. So how does it work behind the scene? RedisGears is loaded into Redis, and all the core is written in C, directly in C. So all the cluster management and the execution operation and the MapReduce is written in C. The C exposes C API that's used by the Python interpreter. And the Python interpreter uses it to perform the Gears operation directly on Redis. So I want to talk a little, let's skip this. I want to talk about what good and what is the advantage and the disadvantages of using Python directly on Redis, embedded on Redis. So the advantages is first it fast, right? This is the direct function call. We can, they use the same memory, and there is no need to copy the memory and stuff like this to outside process. And the last bullet is important because it's easier to control how many memory the interpreter use, and I will show you how we do it in a little. Okay, so why is it not good to use the Python as embedded inside Redis? First, the same client used the same interpreter, so they actually share global variables. If one client is using a variable called A and another client uses a variable called A, and those variables are globals, they will see the same values. If I increase it and another client increase it, it will increase, right? It will increase by 2. So I'm going to talk about how we solve it in a minute. The second bullet, currently we do not have a solution for it. We cannot run 2 clients simultaneously in 2 different threads because Python is not really multi-threaded, right? We have a global lock for Python, and the only single Python code can run at the same time. But we will probably have a solution for this in the future because it's under development currently that we can use sub-interpreter to run Python code simultaneously with different threads. So I hope this will be solved in the future. And the last disadvantage is that a bug in the Python interpreter might cause Redis to crash. And it's even worse with this, because if there is a malicious code that somehow can run on the Python interpreter, then it can actually run directly on Redis. I tried many things or many ways to solve it, but currently we do not have a full solution. And if someone knows or had experience with running the Python code in kind of a sandbox, then I will be happy to talk to you after this talk. Okay, so I said that the first problem is with global counter. Two clients use the same global counter, for example. So Python comes with an ability to use sub-interpreter. Sub-interpreter is an almost totally isolated environment for your Python code to run. It's almost isolated because actually it's still the same process. So file descriptor, for example, if you list all the file descriptor of the process, you will still see the same file descriptors. But I believe that to run a Python logic, it's probably good enough. And RedisGears make use of sub-interpreters to isolate clients and let you run in an isolated environment. I wanted to talk a little more about sub-interpreter, but I think that the thing that will be more interesting for you to see is that how RedisGears can manage the memory that the Python interpreter uses. So when you use Python on the C-level API, you can set the allocator that the Python interpreter will use. So what we did is that we created a specific allocator for the Python interpreter that uses the memory from the Redis directly. And you can see here in the code that before I start the Python interpreter, I actually set the allocator that the Python interpreter will use. And the allocator uses my direct functions. So when the interpreter will try to allocate memory, it will get here to my function, and I will return him the memory. And I use the Redis allocator to allocate the memory. So currently we are not doing it, but it's possible to limit the amount of memory the interpreter uses. And moreover, it will be possible to limit the number of memory used by a single client. So we can control how many memory each client uses, and we can, you are nervous, we can control how many memory each client uses, and we can limit it such that one client will not explode the amount of memory and will not explode the machine. So this is another cool stuff that we did with RedisGears. Now, Python and clustering. So I already talked about clustering. I want to say one thing about it. When we create an execution and we create our Lambda function, we need to serialize and deserialize those functions between all the shards. The way we do it is we use the Cloud Picker library in Python that allows you to not just serialize and deserialize dictionaries, it also allows you to serialize and deserialize the function itself. And if this function uses another function, it knows how to serialize it too. So this is what we did, but there is some cases where we can't actually serialize the data, and those cases are when you use native C implemented object like matrices and tensors and stuff that are implemented directly in C. Currently, if you try to serialize and deserialize it, you will get an error. Maybe in the future we'll come up with a solution with maybe a callback that will serialize the data. But currently it's on the user responsibility to transform the data before you pass it or send it to another shard. So this is currently the user responsibility, and this is why I said before that when you move to cluster, it's almost always smooth, but there are some use cases where it will not be smooth. Now, I talk about tensors because I want to give, how much time? I want to give like 5 minutes to Redis AI. Redis AI is another module that we develop in Redis Labs. And Redis AI allows you to run tensors and directly on Redis. Why is it good? Because most of the time your data is already on Redis, and you don't want to get the data out in order to classify it, for example. So what Redis AI allows you is to classify directly on Redis and get directly the results. And if you combine Redis AI with RedisGears, you can achieve much more. Because Redis AI also exposes a C API that can be used by RedisGears to classify data. So here, for example, you can see that I'm calling directly to Redis AI function in RedisGears code. So those two modules can cooperate together to achieve much more. So for example, RedisGears can allow you to change your data before you send it to Redis AI. If you have an image, you can resize it with RedisGears and then send it to Redis AI for classification. And this is exactly what we did in my last example. And I want to show it to you. So what I'm doing here is I'm setting up a Redis server with Redis AI and RedisGears inside it. And you can see here that now RedisGears said that Redis AI API loaded successfully, which means that RedisGears understood that Redis AI is loaded also into Redis, and it can use the capability of Redis AI to classify data. Now, I have two websites, let's call it. The first website on the left, I think, will show you, will show you all the images which are captured by my web camera. So you can see me. And on the second website, you will only see cats, because Redis AI and RedisGears works together. All the images are passed into Redis, resized and rechanged, so Redis AI can classify them. And if there is a cat inside the images, Redis AI will tell, hey, there is a cat in the image, and you will see it on the right side. So now there is no cat in the images, but if I will if I will show it a cat, you can see that you see it on the right side. And this example shows the capabilities that you can gain by combining different modules together and achieving much more than you can do with a single vanilla Redis. I know that it was a little short. I will be glad to talk to all of you if you have questions. And now if you have questions, then you can also ask.
Thank you very much. Unfortunately, we don't have time for Q&A session, but you can go to the speaker zone and discuss it there.
No, but we need to give the gifts.
I will give gifts to you, and in the discussion zone, you will
thank you.
Distribute them. Yeah. Thank you very much. It was very impressive.